Ah. Hello interwebs, welcome to Let's Fix Computers. Look at this heckin' PC bag. This is cool, man. I haven't even looked inside this yet. Ooh, it's a Corsair 4000D. Now I've shown off the bag, I'm going to put it on the floor again. Ugh. Oof. I didn't know you could still get like big PC bags like this for going to LAN parties and stuff. Ugh. Huh. It's got one of them bags in it as well. It's a CyberPower PC. I see. Apparently, there is, and I quote, maybe a problem with the CPU with this. I'm going in completely blind, that's all I know. So let's explore together. Let's take this side panel off and just see what we're actually dealing with here. Let's see, does this slide or does it pop off? It pops off. Ooh, shiny. Okay, we've got an Intel something. We've got an RTX 3080 there. Nice. MSI AIO on the CPU. We've got 32 gigs of DDR4, populating all slots. Boo. Got an SSD down at the bottom. Can't see what the motherboard is because it's hidden under the graphics card. Guessing it's a H series. It might be a Z, but might just pop out that graphics card and have a quick look. Let's just turn it on first and see what it does. So I shall plug in the power. All of the ports on the back of the motherboard look misaligned. From about halfway up the I/O shield and back, the motherboard looks like it's bent in somehow. I feel like something is wrong there. I can't see how, but it's not aligned. Power, power, power. Oh, there we go. It's blue. Let's get some capture. All right, we have beep codes. We've got one long beep code and one long and two short. And we're stuck on the VGA diagnostic LED up there. Let's turn that off. Okay. So VGA diagnostic LED, and we've got one long and two short beeps. So we've got quite a lot of information to get started with here. I'm going to take off the back panel as well. I kind of want to see what motherboard we've got, just so I can actually see what CPU this is likely to be. I'm just having a look around the back, see if there's anything screamingly wrong. The RGB controller is loose and flapping around in the breeze. That can be resolved. We've got a 750 watt power supply, 80 plus white. That's a bit disappointing given the spec of this system. That's not a good power supply choice for a 3080 based computer. It'll probably work, but yeah, I would have put something else in. Fine. I want to know what's going on with that motherboard. Let me turn this around. Ugh. So you see how all of these are just completely misaligned? Like these ports just are not remotely aligned. Like, I don't know what happened there. If it left CyberPower PC like that, that's a massive QA oversight. That's not acceptable. Like, you can't plug anything into any of those USB ports at all. That's completely unacceptable. So I don't know whether that's been knocked out of place in transport or something, but the motherboard feels pretty firmly in. Something has gone terribly wrong there. Like, it almost looks like the wrong standoffs are in this case. but I don't see how that would be possible. This is a Corsair case, so it will come with the standoffs pre-fitted. So I don't understand how you could screw that up. I kind of wish I'd... the owner of the computer didn't bring it in. It got brought in by a parent, I think. So I didn't really get a chance to sit down and talk to the owner properly, because my question now is, what's the story with this PC? Is this thing like brand new, or what? Or how old is it? However, I appreciate the fact that one of the problems with buying a system integrator PC like this is if there's a problem with it, you really don't want to send it back to them, because you've got to ship it, and no one wants to box up a PC and ship it. Right. I'm going to take the graphics card out and just see what motherboard this is. What's this? It's a Z690 Pro DDR4. Okay, so that's 12th gen DDR4 motherboard. Very well. Okay, the bad news is I don't have any 12th gen stuff in to test with, so I'm going to be hoping for the best here. Okay. I don't like the way this motherboard is seated. I kind of want to start with the basics, which is start reseating RAM, because we're sitting on a VGA light. You know what? Let's look up that beep code. All right, one long and two short is a VGA or graphics card error. So that tallies with the fact that we had the VGA light on the motherboard. So this doesn't sound like it's to do with memory or CPU at this point. It sounds like it's a fault with the graphics card, maybe. The next thing I would love to do is plug into the onboard graphics and see if we can get an output from there, but I can't because the motherboard is misaligned. So what I think I'm actually going to do is just see what the deal with that is. Well, what I'm going to do for now, I'm going to cheat, and I'm just going to back out the motherboard screws. And that will allow the motherboard to just lift up a little bit so I can plug a HDMI cable into the onboard HDMI. And we'll just see where we get up to. Right, I've got a HDMI cable jammed into the back now. And yeah, the motherboard had to lift about 2 or 3 millimeters. I don't like this at all. I think I am going to have to take the motherboard out just to find out what's going on with those mounts, which means removing the cooler, which is annoying. But it is what it is. Let's see if it gives me a signal from the onboard. I want to be fairly non-destructive here because, for example, if there's an issue with this graphics card, this is a 3080, you know, if this guy's got problems, then this thing is going back to CyberPower, you know, warranty. All right, power on at the back. Nope, same thing. Could that have been 3 long beeps? So we also have to consider the fact that we might have an F-SKU CPU installed that doesn't have onboard graphics. I'm not actually sure what the behavior for that is. However, what I'm going to do next is I'm just going to lob this graphics card into my test rig and see if it spits out a picture, because that means that I can just immediately say, okay, the 3080 is okay. So let's quickly do that just so we can eliminate that. Then I'll probably test with a smaller graphics card that's just a bit easier to shift around. Behold, my GPU test rig. This thing is specifically built for testing graphics cards, and I haven't got it done yet, but I've been working on getting all of the NVIDIA mats and mods tests installed on this thing. We put this thing together on the podcast, Caradog and I, on our Saturday podcast we do, linked in down below on the second channel. And we did do a very brief test. It needs some work still, but as a concept, it's pretty good. So it's only 4th gen Intel, so it's nothing to write home about, but it's good enough just to make sure that a GPU actually starts and runs. Activate. There we go. So the GPU does work. We've got a signal out of that. Grand. Okay. So obviously I could start stress testing it and stuff like that. I'm not going to bother right now. Previously, the main computer that we're diagnosing doesn't post. This graphics card does post. That's what I need to know. This is not stone dead. That's the bit that matters. When we've got the rest of the system up and running again, we can hit it with some stress tests to make sure that the graphics card doesn't fall over. However, it's just installed the drivers for it as well. At this point, we've no reason to believe that this is causing us any problems whatsoever. So we'll shut that down again. Okay, so what next? Well, I'm going to do a BIOS reset. Let's pop this CMOS battery out. I'm going to do a BIOS reset, then I will chuck a different memory kit in there as well, and we'll see if that does anything. If we still get nowhere, then motherboard is coming out so we can actually start bench testing to make sure that this platform actually works. Daisy chaining power cables on a 3080 is not advisable either. I know I just did it on my GPU test rig, but my GPU test rig has a much better power supply than this in it, and we only needed post. Power cycling, that's RAM training. All right, nothing. Let's change the memory configuration. I'm 99% certain that memory is not our problem here. However, it's one more thing that's very easy to try changing before I have to start doing major stuff like pulling the motherboard out. This is the cheapest. Oh my days. Oh, CyberPower, come on, man. This is cheap Team Group RAM, but that's not my issue. My issue is DDR4 2666 CL19. Come on, guys. You get better RAM than this out of a cereal box. I'm not impressed. I don't like hating on system integrators because a lot of the things they do for a reason, but just stuff like that, like 12th gen system with a 3080 and you're putting in 2066 CL19 RAM. Come on, get out of here with that nonsense. Right, here's a 16 gig 3600 kit, 3600 CL16. Like, this is not expensive RAM. This should be standard issue RAM for a gaming PC. It is RGB as well, that doesn't need to be standard issue, but 3600 CL16, just come on. DDR4 is cheap. Why be like that? Why you gotta be like that? Whatever. That's not what's causing problems with this PC. That's the thing. It's easy for me to say that's not very good. However, it should work. So, it should work. All right. Let's just try it with that. I don't think memory is going to make any difference here, but, you know. Nope, same thing. Okay. Okay, I'd like to try a different power supply, but this doesn't feel like a bad power supply to me because it's giving a specific error message. If we were getting nothing, if it was sitting on CPU or something like that, or even the DRAM light, I would be suspicious of the power supply. But the fact that it's going over to VGA and giving us a beep code makes me think that this is not a power supply issue. Let's put the original RAM back in, and I'll tell you what else I'm going to do. One more thing. I'm going to drop in a different graphics card just in case we have an F-SKU CPU in here. And this is actually still just a graphics issue. Let's actually stay on top of the error codes we've got. We have a VGA error code, so let's stay with graphics solutions. 1060 6GB card. It's EVGA's compact one. Really nice test card, this. It's got enough power to actually be a test, but also it's simple enough that anything can run it. Right, here we go again. Not expecting any change from this, but systematic approach. Oh, we might have something here. It's posted. We're booting. Interesting. All right, we live. Okay, I don't know the password for this, so I'm going to shut it down and drop in a test SSD so we can boot onto a system that I know the password for, and we can actually have a closer look at what we're dealing with here. So at the moment, highly likely that we have an F-SKU CPU in here, which is why it wouldn't post on the onboard graphics. I still want to sort out why this motherboard is crooked in the case, but it looks like that's not relevant to our problem. Oh. And it's died again. Same issue. Awesome. We have an intermittent fault. I love intermittent faults. Okay, you know what? I'm just going to try that one more time just to see if I can get it to start. I don't know what I'm expecting to this. I just want to see the rest of... Well, I don't know. No. Okay, let's take this out the case, I think. So when you get faced with what could potentially be an intermittent fault, it becomes really important to start removing variables from the system and get right down to the basics. You can do a bare boot just by taking out any add-in cards like this Wi-Fi card here, and also, you know, disconnecting the front panel USBs, all of that malarkey. However, by the time you've done all that, you're more or less only one step off of just taking the motherboard out of the case and running it on the bench. And then you can be certain that there's no shards of metal jammed into the back of it or anything nonsense like that. We're also going to be testing on a different PSU when we do that, I think. Yeah, well, we'll come back to that. If it works out of the case on a different PSU, then we know it might be a PSU issue. Oh, damn, that's in tightly. Damn it. RGB. Oh, you're going to be zip tied in, aren't you? Fudge. Oh, good. It unclipped. Phew. All right. Good grief. I'm going to have to... Oh, I'm fine. Right, I'll come back to that. Deal with that in a bit. Get this sodding motherboard out. Man, I get that system integrators have to do everything up tightly so it doesn't come loose in shipping, but this is ridiculous, man. And the problem is, yeah, the standoff is turning. Yeah, the standoff is turning on that screw. The problem is it just means that maintenance becomes this, where everything is laser tight in. I'm going to have to get the big boy screwdriver. You shouldn't need it. All right, now we're cruising. That's going to pull out a standoff, but so be it. Motherboard should now be clear. Okay, the CPU is a 12900KF. So 12900KF with 2666 RAM, everyone. Bing! Why is that even an option, CyberPower? Why is that even a choice you can make? Why is it possible to select a combination like that? It shouldn't be. However, also, it is an F SKU. So that does explain why we're getting no output from the onboard HDMI. The onboard HDMI won't give us anything because we've got a KF SKU CPU in there. Fine. All right, so let's get this thing hooked back up again and we'll see if it'll start on the bench for me. And so what we're going to be doing now, we're just going to be working back towards something that functions. In an ideal world, a 12900KF, we kind of want the extra 4-pin CPU power cable connected up there. However, I don't have an extra EPS on this test power supply because generally speaking, you never need the extra 4-pin. This is probably one of the only CPUs where I'd actually say, actually, you know what, you probably want the extra 4-pin connected. So anyway, let's see if it'll start for me consistently now. So CPU fan 1, stick you in there. Doesn't need to be a good mount, it just needs to stop it from blowing up. All right, so I think it's going to start in this state. And what we want to do is just make sure it starts consistently. So I'll stick in the beep speaker just because that was giving us a nice audio cue as to when it was and was not working. And where's my start button widget? This is a widget that I made myself. I've got a little connector block. These used to come with motherboards, and the idea is you would connect all your noodly boys up to one of these connector blocks, and then you'd have just a single plug that goes into the motherboard. I've cut the end off of it, and I've soldered on 2 micro switches from an old case and a couple of LEDs. So now I've now got a power button and a reset, hard drive LED and a power LED, all on this little block that I can just plug into a standard motherboard. That doesn't work on some of the older Asus motherboards that have non-standard pinouts. However, most motherboards have the same pinout. Off we go. So looking for these lights up here as well. It's on VGA. If that goes out, we win. No, still nothing. Okay, well, we've broken down this far, so let's... that's not coming out nicely. There we go. We've broken down this far, so let's inspect the CPU. Let's take a look-see. Okay, bottom of the CPU is nice and clean, nice and shiny there. it looks like there's a shadow on the CPU there, but those pins are just slightly smaller than the other pins, so that's not a smudge or anything. That's just pin size. And the LGA is as clean as a whistle. Absolutely no complaints about that. So I'm just catching it in the light and looking around at different angles just to see if anything pops up. However, I'll just angle that a little bit just so you can see it. You can see all the pins there. You've just got two solid shades there you can see in the light. As you move it from one side to the other, if there's any bent pins, they'll stick out like a sore thumb. You'll see a big dot where one of the pins is not reflecting like the others. So easy to see, no problems there at all. So fine, let's stick that guy back in and leave him alone because there's no problems under there. I'm just going to have a good look at the PCI Express 16 slot as well. Can't see any issues with that. Okay. Let's spin it up again. I got bad vibes about this one. Ugh. Okay, power off. What if I put the graphics card in a different slot? Let's move down to here. This is like a 4x slot, this, so obviously you'd have heavily decreased GPU performance. But we don't care about GPU performance right now. We care about getting the system to switch on. This board is weird. You push the power button and there's a delay. Ah, that's a post. All right, we're booting. I think we've got a bad PCI slot on this motherboard. The good news is the motherboard is probably the cheapest component in this system, except for the RAM. Switching out the motherboard, that's not the end of the world if that's what needs to be done. And if anything, we could put in a better motherboard. This motherboard isn't terrible. It's probably the cheapest Z690 that money can buy, but it is a Z690. So I don't hate this motherboard. It's a bit of a weird one because, you know, Z690 with this tiny little heatsink on the PCH. You know, it looks really weedy, this board. However, other than potentially being faulty, there's nothing wrong with it. I think it's a bad pairing for a 12900 KF, but then so is the RAM kit that's in here. But these are, again, this is one of the problems with system integrators. They've given you 12900 KF, RTX 3080, and the cheapest motherboard, power supply, and RAM that will actually work with that. You know, and what really annoys me is most of the time you can custom spec a computer to exactly the same price as what this system probably cost. You could go and buy all the parts yourself and have better parts. So that kind of bothers me that system integrators just cut those corners, yet still aren't really that competitive on price, in my opinion. That's a sweeping generalization, though. There's more to it than that. You've got to pay people. You've got to run a business. Fine. All right, everything is detected as it should be. I could start throwing stress tests at this, but we're not ready for that yet. So I'm going to shut this down again. And I'm just going to turn it off and then just turn it on again and just see if it starts a second time, because this could have been a fluke. That might have been a fluke. Power off. Power on. Yeah, first time. Okay, it definitely seems like we have an issue with the PCI Express 16 slot. That's definitely what that feels like. Shut down. So let's move back to the other slot. Power on. And we've got problems. So, the top PCI Express slot, that is wired directly into the CPU. We've already checked the CPU for issues. So we know that there's no bent pins or dirty pins underneath the CPU. So what I'm going to do, I'm going to just unplug the motherboard and stare at it real hard and check if I can see any visual problems with the traces or anything like that. And I'll just see if I can spot anything that might give us hints as to why this top PCI Express slot doesn't work. Nope, no visible issues at all. Everything looks really clean, looks like it's brand new. Let's hook it up again and just try it one more time. Because it did post once for me on that slot when I initially put the 1060 in. The first attempt with the 1060 worked. So there's obviously something going on. If I put in a card, is it seating nicely? Yep, it's in the slot. Maybe some board flex has pulled away the PCI Express slot pins slightly. I don't know if that's a thing that can happen. Not something I've seen before, but guess what might be interesting is if I put the graphics card in a low slot and then stick like the Wi-Fi card in the top slot and see if the Wi-Fi card is detected. That would be very interesting. That could potentially tell me a loss of information. Cool. Right, power on. No, it's not starting again. Okay, let's do that then. So, graphics card out. And the Wi-Fi card is detected. It's not picking up much because it's got no antennas plugged into it, but it is detecting networks. However, it's like a 1X card, so that doesn't tell me much. I could put a... Let's try a 4X card in there. All right, so here's a 4X card. I've just got an M.2 SSD taped into this PCI Express adapter. So because this is a PCIe 4X, it's using a few more lanes than the Wi-Fi card with a bit more bandwidth. So who knows? Let's try that out. See, if this was just a matter of 1 or 2 bad connections, then I would be expecting like maybe the graphics card would only work at 8X or something like that, which is why I'm trying to put in something that's got some extra lanes to trip it up. And my SSD is detected. This is a folder. I could put in a really basic graphics card. Let's try it with something really basic. AMD Radeon 7 240. This is an 8X card. Only those pins are actually hooked up. So we're just slowly increasing the number of PCI Express lanes we're using. Let's see what it thinks about that. Let's see if we can find out exactly what the limit is, what it can and can't do. So we'll see if it works with this just straight off. If this doesn't work, we'll stick the 1060 in that slot, boot off of that with this connected, and see if they're both detected by Windows. Uh-oh. The fan on that didn't start. Did the fan on the 1060 start? I'm not sure. The fan on this thing isn't spinning, but also this is a very old graphics card and I don't know if it even works. So this is not really a good test, but let's see, device manager. It's not detected. Okay. All right, let's shut it down. And I'm just going to try this graphics card in a low slot just to confirm that it works. Because this test is kind of irrelevant if we're using a dead graphics card. The fan on this card is spinning now. Yeah, and it's starting. Maybe a power issue? So unfortunately, the only real way we're going to know whether this is CPU or motherboard, I don't think it's the CPU. Because also, it's the old phrase I used to say all the time, it's never the CPU, unless it is, but it's never the CPU. That applies to desktop systems. Laptops, completely different animal. However, with a desktop, it's never the CPU, unless it is. So I think it's a lot more likely to be a motherboard. Also, getting a replacement motherboard in is a lot cheaper than getting in a replacement CPU. So I think that might be what I have to do to prove this once and for all. I also just want to know if it's like fixable or not, because if we can narrow down exactly what the fault is, we might be able to approach repairing this. But yeah, I can't see anything wrong with that. None of the pins look like they have a bad connection. I think the graphics card won't power on if it doesn't initialize, perhaps. It's a shame, because if this was an AMD system, I'd have different CPUs I could test with. So let's do some voltage checking. On a PCI Express connector, this bit here, these first set of fingers, this is power. There's a 12-volt rail and a 3.3-volt rail there. Then all of this stuff backwards is then data. So if we check the first 3 pins and the last 3 pins, we should find 12 volts and 3.3 volts respectively. Now, I've just quickly buzzed backwards and found that these capacitor points here, this is input capacitance for those power planes. So I can measure this empty pad here and this empty pad here to get the 12 volt and 3.3 volt rails on this motherboard. So let's power it on and see if the card is actually getting power from the slot. Because my guess is there might be a missing rail maybe. Because these smaller cards we're using might only be running on like 3.3 volts. It's entirely possible. So I'll put my left probe on some bare metal for a ground. Let's see what this does. Oh, that don't look good. What's that? Was that high and then sagging? All right, this is going to look super sketchy. I'm going to measure directly off of the graphics card because I'm really confused. I don't like those measurements at all. So let's go to a known good ground. Good old screw hole. So we're in a no-post situation. I've just unplugged the beep speaker so it's not beeping at me while I'm trying to take measurements. Let's see what you are. Okay, there's our 3.3 volts. 3.3 volts is alive. And that should be our 12 volts. And then that should be ground. Yeah, there's no 12 volts on this PCI Express slot. So let's go to the rail, it should be again. That should be 12 volts. There's no 12 volts coming out of this PCI Express slot. And now we can prove that. Let's move it over to a known good slot. My apologies for the janky camera angles on this, but I'm not accustomed. Power on. All right, so the board is actually going to power up and run now. And now if I measure that same spot, oh, I've got my probes the wrong way around. Which doesn't matter for voltage, you'll just get a negative reading, but just so it's not confusing. And there's 12 volts. All right, there we go. That's our diagnosis. The PCI Express 12 volt rail is not up on the main PCI Express 16 slot. That is why that's why graphics cards are not working in that slot. It is probably intermittent because it did kind of work once. So this also proves that it's a motherboard fault and not a CPU fault, because the 12 volt rail is nothing to do with the CPU. The CPU has no control over that. That's the motherboard's job to put 12 volts onto that slot. Okay, right. So I wonder what we can do about this. Could we fix this? This is a very interesting fault that we found. I kind of like it. I just don't know if I can do anything about it other than replace the motherboard. So let's see if we can figure out some basics for this. So our 12 volt rail is going to be that guy there. It's not going to be shorted to ground, otherwise the thing wouldn't start. But let's just check the resistance on it anyway. So we have 28 kilo ohms of resistance. So the rail isn't shorted. So let's go from the 12 volt rail to this MOSFET. Is this MOSFET the power source? It is. So this MOSFET here powers the 12 volt rail to the PCI Express slot. I wonder if it does for all of the other ones as well. We can check that. If I just probe from that capacitor, and if I just poke the low pins here on these slots, oops. No, it doesn't. And now I think about it, that's obvious, because otherwise none of the slots would work. Are the other slots all common together for 12 volts? Yes, they are. So all the other slots have their own 12 volt source. However, this one has a dedicated 12 volt source, which makes sense because you expect to have a graphics card in here that's going to be pulling a large amount of power. So it has its own dedicated power supply. So somewhere there'll be another MOSFET, I'd imagine, for these guys. No idea where. Or maybe they just run off of ATX 12 volt. Not sure, not an ATX motherboard expert. Fine, okay, so is this guy working? I mean, it's not shorted, but let's check it's... How is this guy wired up? Okay, it looks like these side tabs are connected. They're not always. Right, so we've got the input is the flat tabs around it. Then we've got these 3 pins are the output, and then that pin there is the gate, which goes back to the driver, which might be to do with this circuit here. So let's measure from source to drain. That looks good. I'll check the other way. And reverse my probes. And we've got high resistance there. Okay, that makes sense. So possibly an issue with the driver circuitry. I don't know if I don't think I'm going to be able to fix this. I just want to analyze it. So the first step toward fixing a fault is being able to identify faults. So I want to identify this. So here's the super duper close-up of that area. So as I was saying, we've got these tangs around the outside are the input. So that's probably coming from just the 12-volt rail on the motherboard. Then we've got these 3 pins here are the output going down. Then that is the gate, which is switching the MOSFET on and off. So this is going to be the controller for that, because you can see that pin there goes on to this pad. So it's got a feedback pin there. So this chip is monitoring the voltage of this rail. So this is almost certainly the driver. One of these pins, maybe that one there, is going to go back to that gate through these vias. So we've also got, these are empty slots where you could put capacitors. So that means this is going to be a ground pad. So that's its ground connection, that's its feedback. And you can see how we're starting to build up a picture of what this circuit is doing without knowing what any of it is. So the question would be, if there's a fault with this guy or with this dude, it's hard to tell. I guess we could power the board on and see if there's power getting to here, which surely there must be, but if there wouldn't be, that would explain why it doesn't work. So let's measure that. Right, the board is on. So black probe on ground. So we should find that there is no power here. Ah, now there is. Does it only fall down if there's a load there? Okay. I'll power it off again. Let's put the graphics card in. Right, so we've now got 12 volts there. We didn't before. Did I just have bad probing? Ah, but the card still doesn't have 12 volts. Am I probing the wrong place? No, perhaps. The 12-volt rail is up, but there's a bad connection at the slot. I'm going to reflow the slot. Let's get physical, everyone. So is it just me, or do those solder joints to those pins look really crap? Could that be our... Oh, look at there. Look at that. There. Dry joint. Bingo. Oh, that's it. We've got it. Yeah. Oh, that was satisfying. So I'm going to put some flux in there. And warmed up my soldering iron. And let's just see if I can get in around these capacitors. I don't think I can. What if I come in at a weird angle? Might need to add some more solder down there. I'm just trying to retouch those joins. Oh, I'm just touching the plastic a bit and I don't want to. I really need a proper TSKU tip. I thought the tip I had was the TSKU, but I think it's a TSK. There is a smaller one and I need a smaller tip. Ah, all right. This is awkward. You know what? A wedge might suit me better. Let's change out. There we go. That's a good flow. That's what I needed. How are you looking now? Oh my God, what is with this pin, man? I cannot oh. All right. There we go. They're all done. Let's squirt a little bit of alcohol in there and just wipe away the flux. Well, I'll try. I don't think I can get my toothbrush in there. No, my toothbrush cannot reach down in there. Okay, paintbrush. Okay, there we go. I'll get a bit more vicious with a brush afterwards on this. We'll do that in a sec. Let's check the other side. The good news is this side should be really easy to do. Yeah, that all needs doing as well. Right, this side will be a doddle because I've got no obstructions now. Get some flux going in there. Good. Right, am I going to have to check every single join down this entire sodding slot now? Yeah, the rest of these are okay. I think this end of the motherboard tends to get a lot of abuse when connecting and disconnecting a GPU. So I think that's why we've got problems there. That guy looks bad, but I can't poke it. That's on. Right down under there. That's good. It's just the end couple. Now those have been reflowed. Those are okay. Yep. Okay, I think we're set. Here we go, everyone. So I'm going to just lob a graphics card in there. Not going to be careful. I'm not roughhousing it, but I'm not going to be careful with it either. I'm just going to pretend that I don't know that that slot was delicate, and we'll see if it breaks. Okay, wish me luck, everyone. Power on at the back. Blammo. GPU fan is spun up. Oh, I haven't got the HDMI connected. Ba-ba. Cool. All right, so I guess we just go all in. I'll shut it down. I'll start it again. Good. Good, it works. So how much do I believe? Right, I think we're all good there. The rest of the slot is a reinforced slot. I think that was manufacturing, if I'm honest. I think that was just bad manufacturing, because the rest of the slot is a reinforced slot. It ain't coming off of the board because it's the rest of the slot has got a load of plastic anchor points, and it's got metal reinforced anchor points on it as well, which incidentally do stop just before the power. So yeah, the power ones have got a little bit less reinforcement. Maybe there was a bit of wiggle on the end there. Maybe when the graphics card was put in, it was just they were having trouble fitting it in, and it got rocked and nudged, and it just broke those joints. But I mean, you saw them under the microscope. They weren't that good. They weren't very good joins in the first place. So make of that what you will. Either way, I'm going to put this back in the case and rebuild this PC. And I'm going to slap the 3080 in there, and I think it's going to work. All right, let's start putting things back in. So on the motherboard, I've rescued this standoff that came off on the AIO, and I've fitted that properly and made sure these are nice and tight. I've also migrated the SSD up to the top M.2 slot, because that's the one that goes to the CPU. So you'll get slightly better response times, and just in general, there's kind of just no reason not to have it there, all things considered. If you're ever in doubt, you can look on the back and you can see the traces from the M.2 slot, which you guys probably can't see on this camera, but they go from there and they go up to the CPU. So that's how you know which one is connected to the CPU. So let's, oh God, we've got to look at those sodding standoffs as well. All right, hold up. Standoff coming out. Nope, the standoffs are all the same height. So why doesn't the motherboard line up when it's fitted then? This is the crappiest I/O shield I've ever seen in my life. Maybe the I/O shield is just bad. I think it could be. This is why all motherboards should just have built-in I/O shields these days. I'm really amazed that anyone is making enthusiast boards that don't have a built-in I/O shield. But then again, this board is the cheapest Z690 that one can imagine. It is literally all expenses spared. I'm just going to see if I've got any paper washers that I can pad up this screw with, because that'll just lift the board up slightly so it clears the I/O shield properly. There we go. These paper washers used to come with really cheap cases. Never understood the purpose of them. However, I'm going to try and get a couple under that screw there. This is going to be really hecking awkward. There we go. Yeah, that's great. And as you can see, with that padding in there now, the board is sitting at the correct height. So no idea what the root cause of that is. However, we fixed it. Right, now before we plug in the power to the graphics card, I'm just going to see if we've got another PCI cable hanging out around the back, because shouldn't really be daisy chaining a 3080. Feels like a 3060 or something like that, it really wouldn't matter. 3080, ugh, not a fan of that. There we go. Right, it breaks my heart to have to put a second PCI Express cable up here and have these guys a little bit more on show, whereas previously we had a neat daisy chain going on. However, the 3080 and the 3090, they do have nasty power transients on them. And while this graphics card isn't going to pull much more than 300 watts sustained, which one 8-pin will manage, realistically, because of the peaks, which might peak up to, you know, 400 watts, maybe 450, that kind of area, you don't want that running down a single wire, especially because also this power supply, it's good enough, but it's not a brand that I know, because the brand isn't written on the side of it. So I'm not going to trust these with the life of this card. So we'll run 2 of them, so now it'll have an easy time of it. We may as well just give it the best possible chance it has. Right, let's make sure that runs before we put all the side panels on, and then we are done. And our diagnostic lights are hidden. There we go, there's the post anyway. Okay, there's nothing stopping me from giving it a quick belt now, because we have everything connected up in the appropriate manner. So while I've got it running, I will quickly just I'll quickly just hit it with a load. So I'm going to quickly throw superposition at this just to stress the graphics card. And we're going to go 1080p extreme because we've got a 3080 here. Go! There we go. We're starting to get some heat out of that GPU now. It took it a while to heat up this enormous heatsink that's on it, but I need to set the fan curves as well. Because I reset the CMOS, we've got very aggressive fan curves on everything. All right, and that score is about what I would expect to see from a 1080 10 gig as well. So that is on point. So we know that it's running correctly as expected. Good. Right, I'm going to throw all of the covers on this, and I think we're done. Right, there we go, everyone. I've just quickly dived into the BIOS and set the fan profile, so the fans are now nice and quiet. I've just put in a conservative profile that just keeps them nice and low up to 60 degrees and then starts a steady ramp up from there onwards, which will do just fine. And we are into Windows on the customer's SSD. That's it. So thank you very much for watching, everyone. That was a really interesting fix, in my opinion. That's my first time actually approaching an ATX motherboard repair. It was a very simple fault with it. However, I'm kind of proud of myself for actually looking instead of just going, it's a motherboard fault, get a new motherboard. I don't think, I think that was a very lucky find. However, sometimes there's a lot of mileage. You know, you're not going to find the lucky fixes if you don't look for them. That's the moral of the story there. So yeah, I hope you guys learned something. See you next time. Bye.